Hey everybody, today we're talking about isosceles and equilateral triangles. This is the third section of Unit 4. So an isosceles triangle, there's a few things going on here. One, there's going to be two legs, okay? And the legs are going to be congruent to one another. Okay, those are the legs. The base is going to be the non-congruent side, which is down here. The base angles are the angles opposite the legs, okay? The vertex angle is the angle at the vertex. Who knew, right? And there's a few things here we should take note of. One is that the angles that are opposite the legs are congruent because there's a relationship that exists there. There's a relationship that exists between angles that are opposite of a side. Okay? So when the sides are congruent, the angles that they're opposite to would also be congruent. That's basically it. That's pretty much it. So let's take a look at some of these examples. Now, I'm going to zoom in here because they're kind of small. Okay. So name two unmarked congruent angles. So these are marked, so we can't do that. However, we have two sides here. I'm going to trace this so it's a little easier to see. So those are congruent. Those sides are congruent. Therefore, the angles that they're opposite are congruent. So therefore, this angle and that angle would both be congruent. So we're going to call that angle ACB and angle ABC. Okay, name two unmarked congruent segments. Well, we know these two, let me go ahead and use a different color here. We know those two angles are congruent, therefore the sides opposite of them are congruent. So these two sides would be congruent, so it would be AD and AC. Okay. Alright. Down here, I'm going to zoom in a little bit because this one's a little longer so it's hard to see. There we go, okay. Name two unmarked congruent angles. So it's actually easier to solve this problem if you block part of it. Your brain will process it better, at least mine does. So we notice that these two sides are congruent. Therefore, the angles that are their opposite will also be congruent. So we're going to go ahead and mark these as congruent. And notice I'm using a different number of arcs to not confuse myself with the other arcs here. So let's name those angles. So FGJ and angle FJG. Name two unmarked congruent segments. So again, I'm going to block part of it. I can see the two base angles, therefore these are the legs. So GH and JH. Okay. All right, let's take a look at these. Yeah, this one. It's on the wrong side. Okay, so find the length of each side in ABC. So I know that these two angles are congruent because of the notation. Therefore, the legs, which are here, would be congruent. So I can just set these equal to each other. So we're going to say 3x minus 5 is equal to 6x minus 35. And we're going to solve for x. So we're going to say minus 3x minus 3x. Cross those out. Oh, I shouldn't have crossed it out, but whatever. We have 3x. Use a different color. 3x minus 35 equals negative 5. We're going to add 35 to both sides. It means we're going to have 30 equals 3x. And then we're going to divide both sides by 3. And x will be equal to 10. We're not done though, because it's asking us to find the length of each side. So we know this is 10. Let's go ahead and plug that in. So 3x minus 5. So 3 times 10 minus 5. So 30 minus 5, and that's 25. That's 25. Now these are isosceles, so these should be the same, but let's just check it to make sure. So 6x. So 6x minus 35. 6 is 6 times 10 minus 35. 60 minus 35. That's 25. So it does work. Awesome. Okay, cool. That's isosceles. That's how basically you work with isosceles triangles. Now, equilateral triangles are triangles where, triangle is equilateral if and only if it is also equiangular, which means all equilateral triangles also have three congruent sides. Three congruent angles, and the measure of those angles would have to be 60 degrees. Okay, so this would be an example of a equiangular triangle. It's also equilateral. Let's do a few examples here. Let's zoom in the other way. Okay. So we have, it's a little hard to read that, it's 8, 8, and 60. So find the measure of each angle, find them each measure. Okay, so we're looking for the measure of angle y, we're looking for the length of yz. So we know these are the same, and we know this is 60. So if these are the same, that means these two base angles are also the same. So we're going to call this 60, x, and x. So we're going to say 60 plus x equals 180. We're going to go ahead and solve for x. So we have 2x plus 60 equals 180. We're going to subtract 60 from both sides. That means we're going to have 2x equals 120. Divide both sides by 2. And x would equal 60. So you look at this and you say, oh, guess what? This is an equiangular and equilateral triangle. It sure is. So 60 degrees. So if it's equiangular, it means all three sides are the same, which means that this third side has to be the same as those, which means it's 8. Okay. All right. Over here, okay, these are two base angles. So this looks like an isosceles triangle then. So these would be the same because they're the legs. And we have to find m. Okay, so we know these are the same, so let's assign variables. So we're going to say x plus 120 equals 180. And that's going to be 2x plus 120 equals 180. Let's subtract 120 from both sides. So 2x equals 60. Divide by 2. And x equals 30. And that's it. So the angles would be 30, those two base angles, 30 degrees. Pn, so these have to be the same because the base angles, so this would be 11 centimeters. Okay, questions on that? Hopefully not. And yeah, let's go to the last part. This is an interesting one here. So find the value of all the variables. Okay, so these two angles, let's rotate it. Here. You can tell these two are the same, so therefore these would be the same. Right, because it would be the base angles. If this is 2x, that means this is 2x. Uh-oh, guess what? They're all the same, which means this is an equilateral triangle, also an equiangular triangle. So yeah, let's find the angle first. So we're going to add these together so it's equal to 180. So 2x plus 2x plus 2x equals 180. 6x equals 180. Divide by our coefficient, which is 6. And x equals 30. Okay, so x is equal to 30. We had one variable. Now we need to find y. So we know these, because all the angles are the same, that means all the sides are the same, which means these two sides are congruent. So 3 is equal to that. So let's solve that algebraically. So 3 is equal to 4y minus 5. And we're going to add 5 to both sides. And we're going to have 4y equals 8. Divide by 4. And y is equal to 2. Okay, so that would be how you solve that problem. Okay, and that's basically it. So that covers the stuff we need to know for Unit 4, Section 3. And we're going to start getting ready for our quiz and test soon. So I hope that helped out, guys. I'll see you soon.